We on? Okay, good morning. This is our lecture number 4, actually. It has to do with development length is our first topic. The second topic is concrete columns. So, we talked about this in class before. Hopefully you remember that rebar is a steel bar that has a size that relates directly to diameter. So a number 3 bar is 3/8 inch diameter, and number 4 is 4/8 or a ½ inch diameter, and so on. Okay, this is used, as we said, everywhere there's tension in beams, so we put it wherever the beam is being stretched. And when we stretch it, we actually pull on the bar. They make these little deformations in there to help us gain a grip. So this concrete has to grab a hold of this bar and hold on to it so that when it pulls, it doesn't slide inside of the concrete. It's actually held. So the amount of hold, the amount of bar I need to hold in order to make sure this bar doesn't slip is called the development length. So if I grabbed a hold of this bar like this and I pulled on it, it's just going to pull out. If I grab a little further, I need a lot more strength, but I can pull it out. There's a point where I grab a hold of it where the grip is strong enough to hold the bar, so when I pull on it, it can't slide. Therefore, the only way for it to break or move is to physically break. So the amount I need to hold it so that when I pull on it, it develops the bar, which means that the grip is strong enough to withstand the pull that breaks it, is called development length. So for this particular unit, it's relatively easy. It's chapter 13.7. So if you go to 13.7, there is a picture that you will use for homework and that you will see on the test. That picture is on page 470. Okay? And it's got a picture of a cantilevered beam off of a concrete column. So if you look at that thing, it looks like this. If I can get some ink, it looks like this, and it does this, and it goes out here, it goes down, it goes back. So that's the picture you should be looking at on page 470. Okay, this is the picture that I will use on the test. So you'll have the same picture. If you look at it, it has a bar. The bar runs right through here. And then it has some little dots going off of it. That would be if we put a hook on it. For us, we're not going to use the hook. And it has dimensions associated with it. Okay, those dimensions are L2. It has a 2-inch dimension. That is the cover required for a concrete column. And then it has LD, and I'm going to make this LD2. Okay, then it also has a dimension L1. L1 is from the face of the column to the end of the cantilever. It also has a 2-inch dimension right here, cover, and it has a LD, and I'm going to call that LD1. Okay, so there's our picture. There's the rebar. This member here from LD1 is a member that has the concrete beam cantilevering out with a rebar. And if you look at it, the rebar is at the top of the cantilever. So it's up top. On our table, we're going to have 2 columns to play with. One is top bar, one is other. So look at it. For this particular problem, this part of the bar here is top because it's close to the top of the cantilever. From here back, the LD2 portion, okay, this is the other. Why? Because if you look above the bar, there's concrete going on forever. Here, you look at the top of the bar, the concrete just goes a couple of inches. So there's a differentiation between the two columns on the table. Okay, we're going to be using a table. That's all you got to be able to read. Somehow put in your notes or note that it is not the table on page 471. It's a common mistake with students. They'll look at the picture, they'll look to the right, there's a table, they use the wrong table. Go back one page to page 469. So table 13.9 is the table you'll be using. So you want to note it. It's table 13.9, not 13.10. Okay? So we look at it. How do you enter the table? Well, the very left column is pretty self-explanatory. It's the size of the bar that's buried in the concrete. So it's whatever size that green line is, a number 3, number 4, and so on. So you got that one. Then you go to the very top. Now it has a series of columns that have rebar that's FY40. So there's 4 columns there underneath the FY40. The next set of columns, 4 of them, is for bars that are FY60. So your first thing then is to figure out what kind of steel you have. That will be in the problem statement. The next one, if you go to the sub-columns underneath each of those, the first sub-column says I have 3,000 psi concrete, and the next set has 4,000 psi, and the same for the 60. So you find your concrete after you find your steel. So I go to my concrete, I got steel 40 or 60, I got concrete 3 or 4. Now I've got one more choice to make, and that choice is based on this. Is it a top bar or is it another bar? So go to whichever column fits the problem statement, and then you're going to crisscross 2 lines, the column line going down and the bar size going from left to right, and wherever you land, that particular number will give you the length of the bar that needs to be embedded in concrete to develop the length of the bar. So probably the easiest way to do it is play with the problem. You're going to be doing 13.7. B, I'll do 13.7a. So if you get to problem 13.7a, take a look at it and see what it says. 13.7a is on page 470. The picture's right above it. So we'll be using that picture as you will on the test. It says a short cantilever is developed as shown in figure 1321. Determine whether adequate development is achieved without hooked ends on bar if LD1 is 36 inches. So I'm going to put that right next to where it belongs. 36 inches. LD2 is 20, or L2 is 24 inches. So that's right from the problem, as it will be on a test. The overall height of the beam is 16 inches. That has some ramifications. For you, it's not a thing you need to worry about. There's some code restrictions based on that height, but we're not going to deal with it. And then it says I've got number 4 bars. So this bar is a number 4, half-inch diameter, and it's got 4,000 and 40,000 for concrete and steel. I'm putting the 40 first because it's the first one I'm going to get in the table, and then the 4th KSI is right below it. So what do? I've got 2 parts. I've got LD1, which is associated with the top bar. I've got LD2, which is associated with the other bar. So I'm going to go to the table. Just go backwards. Common thing. Students go run right up to that 1310 table and start pulling numbers. That's the wrong table. Go back to page 469. Okay? Put your finger on 40 or 60. How do I know which one to use? I read the problem. 40. I move down. Now I've got two sets of columns to pick. One says 3,000, one says 3 KSI, one says 4. My problem says 4. Go to 4. Okay? Now I've got LD1, which is top, and LD2, which is other. So I put my finger on top. I go down to bar number 4, which is 13, 17. Top bar, I need 17 inches. So I need LD1, I need 17 inches. Okay? So this number needs to be at least 17 inches long or the bar is going to slide in it. Move over. Other. Number 4. Starts out with 12, the next number is 13 inches. So LD2 is 13 inches. So I'm going to make a little table right here real quick. This is what I need. This is what I have. This is LD1, LD2. LD1, I need 17. LD2, I need 13. If I look at my picture, it's a simple math problem. L1 is 36, the cover is 2. LD1 is 36 minus 2, which is 34 inches. So for LD1, I have 34 inches. I move and do exactly the same thing up above. The width is 24. Got a cover of 2. That leaves me a remainder of 24 minus 2, which is 22 inches. And it's just like everything we've done in class. I've got what I need and what I have. If I have more than I need, I'm in good shape. If I don't, I got to make a correction. So I need 17, I have 34. That one's great. I need 13, I have 22. That one's great. Okay, what happens if they're not great? So you do the math, you come out, and you need more than you have. What are your options? Well, you've got several. Okay? If you look at the table kind of tells you what you do. If I look at the bars and I look and see how can I get something that's bigger in the table? Well, look at it. If I need something that's bigger, all I got to worry about is two things. If the bar is stronger, if I make the bar stronger, which goes from 40 to 60, it makes sense that I need more grab because it's going to take more force to pull the bar and break it. Therefore, the development length should get bigger. If I've got concrete that's stronger, okay, the concrete can hold better, stronger hands. If I put stronger hands on that and I pull it in order to break it, I'm going to need what? If I've got stronger hands, it needs less hand length to break it if they're stronger. So the development length's going to go down. So if the concrete is stronger, the development length gets smaller. If the bar is stronger, the development length gets bigger. So you've got the components of both the bar and the concrete, and you also have the size of the bar. As the bar size gets bigger, It takes more force to break it. Therefore, it's going to take more strength to hold it. Therefore, the development length is going to increase. So, not only do you have to worry about the bar being the right size, you got to make sure you've got enough to hold it in place so that it can do what you think it's going to do, and you think it's going to stay put and it's going to stretch. If it's in the concrete and it's just sliding back and forth like that, you have no strength in the bar whatsoever. So the development length is critical. It's typically on specs associated with bar diameters. So they'll tell you the embedment has to be 24 bar diameters. How do you do that? If it says the spec says the bar diameter, you need 24 bar diameters to develop the bar. So what if I have a number 4 bar? A number 4 bar is a 1/2 inch diameter. If I need 24 of them, that means I need to bury the bar into the concrete 24 times 1/2 or 12 inches. So the specs normally deal with the number of bar diameters for embedment. And embedment is how much the bar is embedded or buried into the concrete. And that in our case would be LD1 for a top bar and LD2 for an other bar. So you've got a problem to do in homework. If you go to Canvas, please look it up. I think it's going to be 13.7b, but don't quote me on that. Make sure you read Canvas and submit it on the date that Canvas indicates. As stated before, the date has no time. As long as you're in that day, you're fine. So just do the problem and submit it, and Cy will take care of grading the homework, and I'll take care of grading the tests. That's it for Chapter 13.7, Development Length.